Hi guys, so today we're gonna continue solving problems regarding elimination of arbitrary constants. We are now at problem number 4 and we have the equation y sine x minus xy squared minus x equals 0. The first step, the number of arbitrary constants. By looking at the equation, we only have one, and that is the constant k. So it means we will only have to differentiate this equation once. Starting at the left side, I would have derivative of y sine x with respect to x minus the derivative of xy squared, then minus the derivative of our constant k, and equals 0. So for the first two terms here, we will use the product rule. Again, the product rule states that if you have two functions that are multiplied together, such as u and v, its derivative is v times derivative of u plus u times derivative of v. So if I assign y as my u and sine x as my v, okay, its derivative would be by assigning u as my y and v as my sine x, okay, their derivative would be for y, that would be y prime. Now for the derivative of v, derivative of sine x is cosine x. So by following this equation, we will have sine x multiplied by y prime plus u, that is y, multiplied by cosine x. Okay? So simplifying, I will have here y prime sine x plus y cosine x. Okay. Next, for the second term, we will also use here the product rule. So I will have here the derivative of xy squared. And for this term, I will assign u as my x and v as my y squared. Let's now get their derivative. Derivative of x is 1. Derivative of y squared using chain rule, that would be 2y y prime. So the derivative of xy squared would be v du, that would be y squared times 1, plus u dv, that would be x times 2y y prime. So simplifying, I will have here y squared plus 2xy y prime. So I will now plug in these derivatives to this equation here. I will have here y prime sine x plus y cosine x, then minus the derivative of xy squared, that would be y squared plus 2xy y prime. As for the derivative of k, that would be 0. So I will be left here on the right side with 0. Next step here is we'll distribute this negative sign here to these two terms. So I will have here y prime sine x plus y cosine x. Then I would have here minus y squared, then minus 2xy y prime equals 0. So since this first order differential equation no longer contains an arbitrary constant, so this would be our final answer. Let's now proceed to the next problem. So for this problem, we have here the equation y squared equals a times b squared minus x squared. For the number of arbitrary constants present in the equation, we have here two constants. That is the constant a and b. So for its solution, we would have to differentiate the equation y. So I will start here first with the first derivative. So let's get the first derivative of y squared with respect to x, then followed by, before we get the derivative on the right term, it's better to distribute a on these two terms. So I would have here a derivative of ab squared, then minus derivative of ax squared. Now for the left side of the equation, In order for us to get the derivative of y squared, we will use what we call the chain rule. And the chain rule states that if you have a function u raised to n, its derivative is n times u raised to n minus 1 multiplied by derivative of u. So if I let u be equal to y and n equal to 2, we would need to get the derivative of u, and that is y prime. So the derivative of y squared would be, following this equation, I would have here 2y raised to 2 minus 1 multiplied by y prime, or this is simply 2y y prime. So I would write here 2y y prime on the left side. Then on the right side, derivative of ab squared with respect to x is 0 since there is no variable x here. Then minus derivative of ax squared, that would be, if I use power rule, I will bring down 2, then multiply it by a, then subtract an exponent of 1 to the exponent 2. So I would have here 2ax. Next, I can further simplify this one by dividing both sides by 2y. So if I do that, I would have y prime equals negative ax over 1. Next, since we have here the first derivative, the next step is to get the second derivative, or get the derivative of our first derivative. So I would have here derivative of y prime equals, I would factor out negative a, then get the derivative of x over y. So for the derivative of x over y, we will use here the quotient rule. So the quotient rule states that if you have a function equal to u over v, its derivative is v derivative of u minus u derivative of b over v squared. So if I let u be equal to x and v equal to y, their derivative would be, for du that would be 1, for dv that would be y prime. So the derivative of x over y would be v du, that would be y times 1, minus u dv, that is xy prime, over v squared, that would be y squared. Or simply, this is y minus xy prime over y squared. So I can now plug in this onto the second derivative of our equation. First, we will have to get the derivative of the left side. Derivative of y prime is just y double prime. Now for the derivative of x over y, that is what we've solved here, is y minus xy prime over y squared. And notice, we already have differentiated our equation twice, and we still have here the constant a. So the next step here is to remove this constant a, or let's find an equation that we can replace with a. And to do that, we will go with our first derivative, and we will try to isolate a here in our equation. So if I do that, I need to cross multiply y. So I would have here y prime equals negative ax. Then dividing both sides by negative x, I would have here a equal to y prime over negative x. Okay? So I will use now this equation for a, then substitute it to our second derivative. So I will have here y double prime equals negative y prime over negative x, then multiplied by y minus xy prime over y squared. Okay? So simplifying, so I would have here, so this negative cancels out. So I would have here y double prime equals, I will distribute y prime from y minus xy prime. So I would have here y squared y prime minus xy prime, sorry, xy multiplied by y prime squared, then over x times y squared, that would be xy squared. So the next step here is to cross multiply xy squared, so that I won't have a denominator. So I would have here xy squared y double prime on the left side, then equals y squared y prime minus xy y prime squared. Now, next here is, notice we have y on all of the terms of our equation. So what I can do is I can multiply both sides by 1 over y. So I would have here xy prime, xy, y double prime equals, for this one, that would be y prime, then minus x y prime squared. So the final answer here is, I will need to transpose all of the terms on one side of the equation. So the final answer here is xy y double prime minus y prime plus x y prime squared equals 0. So we now have a differential equation free from arbitrary constants. Let's now proceed to the sixth problem. For this one, we have the equation y equals a e raised to x plus b x e raised to x. For the number of arbitrary constants, we have here 2, and that is constant a and b. So let's start by solving the first derivative. I would have here the first derivative of y with respect to x equal to, for the equations on, or the terms on the right side, I would factor out a first, then get the derivative of e raised to x, followed by the last term. I would factor out b, then get the derivative of x e raised to x. So for the derivative of y, that is just y prime. As for the derivative of e raised to x, we will use the formula, derivative of e raised to u is equal to e raised to u multiplied by derivative of u. So if u is x, its derivative would be 1. Therefore, the derivative of x, the derivative of e raised to x is just, following this equation, e raised to x multiplied by 1, or simply e raised to x. So for the derivative of the second term, I would have here a e raised to x plus, for the third term, now in order for us to solve the derivative of x e raised to x, we would need to use the product rule. So for the product rule, if we have the function u and v multiplied together, its derivative is v times derivative of u plus u times derivative of v. So I will let u here equal to x and v equal to e raised to x. Let's get their derivative. Derivative of x is 1. Derivative of e raised to x is also e raised to x. Therefore, the derivative of x e raised to x would be, following this equation, I would have e raised to x times 1 plus x times e raised to x. Okay? Or that would be, if I simplify this one, e raised to x plus x e raised to x. So I would write here b multiplied by the derivative e raised to x plus x e raised to x. Okay? So I can distribute b from these terms here. So I would have here y prime equals a e raised to x plus b e raised to x plus b x e raised to x. Okay? So next is, now before I get the second derivative, so notice guys, we have here the terms a e raised to x plus b x e raised to x, which is our original equation. So what we can do here is, we can simplify these two and replace it with just y. Then I would copy the remaining term. I would have here b e raised to x. So now we can now differentiate this first derivative. So I would have here the derivative of y prime equals the derivative of y plus the derivative of, or before I get the derivative, let's factor out b, then get the derivative of e raised to x. So for the derivative on the left side, that would just be y double prime. For the derivative of y, that is just y prime. Now for the derivative of e raised to x, we've already solved that one, and that is just e raised to x. So I would have here b e raised to x. So next is, notice in our second derivative, we still have the arbitrary constant b, and we would need to find an equation for us to replace the constant b. So to do that, we will use here the first derivative. So I will try to isolate b here from this equation. I would have here y prime, then I would transpose y, so I would have here minus y over e raised to x. So this would be my b. So I would use this equation to our second derivative. So I would have here y double prime equals y prime plus, so my b would be equal to y prime minus y over e raised to x multiplied by e raised to x. Notice I can cancel out e raised to x here. So I will be left with y double prime equals y prime, then plus y prime minus y. I can simplify y prime plus y prime. So I would have here y double prime equals 2y prime minus y. Now the next step here is to transpose all of the terms on one side of the equation. So the final answer here would be y double prime minus 2y prime plus y equals 0.